So, why on earth would you ever want to build an HTTP server completely from scratch? And I mean, really from scratch, starting with TCP, no libraries, no frameworks, just you and the protocol. Okay, let's dive right in.
Well, the reason is actually pretty simple. The Primeagen, whose course this explainer is based on, puts it perfectly. He says this is one of the best exercises out there for leveling up your skills as an engineer. It's all about peeling back those layers of abstraction to truly understand what's going on under the hood of the web.
So, here's our game plan. First, we'll talk about why this is such a big deal. Then, we'll get down to the absolute core foundation, the byte stream. From there, we'll build up to TCP, then figure out HTTP's role in all this, and finally, we'll put it all together to see how raw bytes actually become meaningful requests.
All right, first up, why bother building an HTTP server? This is all about getting beyond the libraries we take for granted every single day, so we can see the web's fundamental principles in action.
That's right. The whole point here is to intentionally avoid those helpful, built-in HTTP libraries. By building our own implementation directly on top of TCP, we get this unique and incredibly powerful view into how the web actually communicates. It's a total game changer for your understanding.
So that brings us to our next big idea. It's all just a byte stream. And here's the funny thing. To really get a handle on a network protocol, the best place to start isn't with the network at all.
Instead, think about something you've probably done a million times, reading a file from your computer. You open it up, you create a little buffer, let's say it's 8 bytes big, and then you just loop, reading one chunk of data, then the next chunk, and the next. It's just a continuous flow of information.
And that right there, that simple process, is the key concept. That's a byte stream. That's all it is, just a continuous, ordered sequence of bytes. The most important thing to remember is you're just reading stuff in order, from the beginning to the end.
Now, this is the big aha moment. You see, the code you write to read from a local file is basically the exact same code you write to read from a network connection. Same logic. So, how is that possible? It's because, as far as our program is concerned, they're the same thing. A file, it's just a contiguous set of data. And an internet connection, well, it's just a contiguous stream of data too. Once that really clicks, all this networking stuff becomes way, way less scary. Okay, so we've established that everything is just a byte stream. Cool. But how do we get that stream from point A to point B reliably across the absolute chaos of the internet? Well, that's where TCP comes in. It's the reliable messenger. TCP stands for Transmission Control Protocol, and its entire job, its one and only purpose, is to take that stream of bytes and guarantee that it arrives complete and in the correct order. No missing pieces, no jumbled mess. It just works. And this shows you exactly why HTTP is built on TCP. You can think of its alternative, UDP, as just shouting data into the void and hoping for the best. TCP, on the other hand, is more like making a phone call. It does a handshake to establish a connection, and it waits for confirmation that each part of the message was received. It's all about reliability, not just raw speed.
You know, there's that classic tech joke that sums this up perfectly. I could tell you a joke about UDP, but you probably wouldn't get it. With TCP, though, you always get the setup before the punchline. Every single time.
All right, moving on up the stack. So, thanks to TCP, we now have a reliable stream of bytes. But what are those bytes? What do they actually mean? At this point, they're just data. This is where HTTP steps in. It's the language, the rules of the conversation. And honestly, the structure of an HTTP message is beautifully simple. It's just text. Right at the top, you've got your start line. That's the main request, like get/cats. Below that are the headers, which are just key value pairs with extra info. Then, and this part is super important, there's an empty line. That's the signal that the headers are done. And finally, you might have the message body, which is the actual payload, the data itself. And here's a fun little detail. Every single line is separated by a carriage return and a line feed, or /rn. I love the Primeagen's little mnemonic for this. He jokingly calls it a registered nurse because it helps you remember the order. R, then N. Kind of clever, right? So you see, without HTTP, that reliable stream of data we got from TCP would just be, well, a meaningless jumble of text. HTTP is what gives it structure and context. It's the part that says, hey server, I want to get this specific thing from this path, and gives it all the other info it needs to make it happen. Okay, let's bring it all home. Final section. From bytes to meaning. We're going to put all these layers together and trace the whole journey.
So here's how it all flows. It starts with just raw bytes. TCP comes along and wrangles them into a nice, reliable, ordered stream. Then, our custom HTTP parser, the thing we're building, reads that stream and starts making sense of it. It finds the start line, it pulls out the headers, and by the end, our main application gets this beautiful, structured piece of data that it can actually use. Method, path, headers, it's all there.
And that is why this all matters. Going through this process completely demystifies how the web works. You start to realize it's not some kind of black magic. It's just layers of simple, brilliant ideas. And when you get that, it empowers you to debug and solve problems at a much, much deeper level. It's like a superpower.
So I'll leave you with this question to think about. What other complex systems that you use every single day are, when you really peel back the layers, built on the simplest of ideas?